In the freezing point depression lab, we are looking at a series of solutions that are made in water. So what we recall is if we have just pure water, it will freeze at 0 degrees Celsius and boil at 100 degrees Celsius. So if it's just pure water, it is a liquid on this range of temperatures. If, however, you add a solute to the water, so now we're going to imagine adding either sugar or salt, or in this case 2 unknown compounds. What we're going to do is extend the range of temperatures where the solution is in the liquid phase. So we are going to affect the freezing point. So the solution will not freeze at 0 degrees, but at something much lower. So we say that the freezing point has been depressed. And the same effect happens on this end. At the boiling end, the solution won't boil at 100 degrees either, but at something higher than 100 degrees. Alright, so this is the reason why we're putting antifreeze coolant in our cars, to keep the water, the liquid at a wider range of temperatures. So in this particular lab, we're looking just at the freezing point depression. And if we do this in sort of a clever way, we can figure out what an unknown compound might be. So there's a series of calculations that we need to do. So take a close look at the background and read through that and pay attention to some equations that are given, and I've just noted them as equation A and equation B. So those are going to be needed as we proceed through the calculations. Alright, so let's take a look, and the first part of the procedure is actually to just measure a sample of water. And so I'm not going to talk about that, but basically it's just to become familiar with the freezing point setup. And obviously, if it's just pure water, then you should see that it's going to freeze at 0 degrees Celsius. That's just to make sure you understand how the freezing point apparatus works. So moving on to experiment 2, and that's where we're actually going to be adding the compounds to water. You are going to measure the freezing point of the solution, and this is in question number 1. Now, I want to just go over a little bit of the notation. Freezing point of the solution is going to be recorded at in degrees Celsius. And then more specifically, you're asked to report something called TD. That is the freezing point depression. It is a measure of how much was the freezing point lowered. So for example, if you were to measure the freezing point of the solution to be negative 5 degrees Celsius, obviously it's going to be lower than 0, so it's going to be a negative number. We say that from 0 down to negative 5, that is a change of 5 degrees. So we say that the freezing point was depressed by 5 degrees. And then obviously this is expressed as a positive value, and this is the one that we will proceed with in the future calculations. So report this value, the actual freezing point, and then report it as a positive value for TD. In question 2, we are reporting some masses for the substances in our solution. Now, we don't actually measure the mass of water when we are doing the lab. Instead, we know we're using 10 milliliters of water. But we would like to know the mass of that expressed in kilograms. So just to remind you of the dimensional analysis that you can do, you can convert 1 milliliter of water to 1 gram. This is the density of water. Alright, so we had that back in chapter 1. And then, of course, we can convert grams to kilograms. All right, so this is going to be your answer in the mass of water. So we're going to have that to you so that you won't have to do that. It's 0.01 kilograms of water. So basically you just have like a little sample of water, and you are going to add an amount of unknown compound. This unknown compound that you're going to add is now going to not make it pure water anymore, but a solution, and you're just going to report that however much you add to make your solution, and this is going to be specified in the procedure. So this changes specified. This is going to be specified in the procedure, and it varies from semester to semester. So however much solid you are adding, you're going to also report that in number 2. Now it'll be the same for unknown number 1 and unknown number 2. You're told to use the same amount in both experiments. Once we get to question 3, we're then starting to do some of the more involved calculations. So in number 3, we're actually using equation A. So I'm going to write it out for you, and then you're going to fill in what you know. Equation A is expressed as the depressed temperature is equal to Kf, which is a constant, times the molality. Molality is a concentration unit. It's kind of like molarity. It's a little bit different. For the purpose of this lab, we just need to know it's a concentration unit. So obviously the more concentrated the solution is, times a factor, the more the temperature would be depressed. So if you added twice the amount of solid, it would be more concentrated, and you would see the temperature go down even more for the freezing point. So what we're going to do is use this equation to find molality. We know the depressed temperature, and we know Kf. For water, the freezing point constant for water is 1.86. So we are using equation A to find the molality. The molality will be Td, which we found, divided by Kf, which is 1.86. So this will then be a value that we use in equation B. So I'm suggesting again not to round. Anytime we have subsequent calculations, it's a good idea not to round until you get to the end. So Td is how much was the freezing point lowered, we know that. Divide by 1.86 and we get the molality. We then take the molality, and I guess this is question 4, and we're going to use another relationship noted as equation B, and we're going to solve for molar mass. So equation B is the molar mass is equal to grams of the unknown compound divided by the molality, which we just found in equation A, so we know both of those, divided by the kilograms of water, which we also found. It will actually be 0.01 kilograms. So we know all of this information. We know how much of the unknown compound we used. We found the molality using equation A, and we can use in this formula to solve. The units get kind of messy here, so I haven't shown all of those, but we can just know that when we're looking for molar mass, the units are grams per mole. Alright, so if you do the reaction twice, you will have if you do the freezing point twice, you will do it once with unknown number 1 and once with unknown number 2. In this formula, the grams will be the same. The TDs will be different, and therefore the molalities will be different that we find. So you're doing this with 2 different compounds. You should get 2 different molar masses, and that will allow you then to answer question 5, which is, which one of these compounds do you think could be glucose? So use the molar mass to help you decide.